Good morning, students. So already we discussed controllability problem, 2 cross 2 matrix and 3 cross 3 matrix. Now here the problem which is given in transfer function, not directly matrix. So you have to convert transfer function into matrix model, then only you can check the controllability. So we will solve one problem using this method. So the transfer function of a control system is given by g of s, which is equal to s plus 2 s cube plus 9s square plus 26s plus 24. So you have to check for controllability. So we can't expect whether the problem which is given only in matrix form. So the system will represent in equation or like this also in Laplace form. Here it is mentioned. So all of you know what is transfer function. So transfer function here represented as g of s, output by input of the Laplace form at 0 initial condition, right? So here g of s is s plus 2 divided by s cube plus 9x square plus 26x plus 24. So this is the transfer function. You have to find out the state matrix. So once you find out the state matrix as it is, you can easily check by Kalman test whether the system is controllable or not. Okay. So you know what is g of s, right? So g of s is nothing but c of s by r of s, right? So so you can write the transfer function as output by input. C of s is output of the Laplace transform in general. R of s means input of the Laplace transform, right? So s plus 2 divided by s cube plus 9s square 26s plus 24. For state space analysis, C of s I can consider as y of s. All of you know that is the output of the system. Then R of s, as I told you earlier, R of s nothing but input of the system. In state matrix we can call it as U of s. It is nothing but input of the system, right? So you can write C of s by R of s. You can write y of s divided by U of s also you can write, right? So y of s, s plus 2 divided by s cube plus 9s square plus 26s plus 24. So for further simplification, I am going to write like this: y of s by, in state variable representation, I am going to write in this format: y of s by x of s into x of s by u of s. So if it is cancel this x of s also, you will be getting y of s by u of s. So I am going to convert in state variables. That's why I am going to write in this form. Okay. So you know y of s plus by x of s is nothing but s plus 2. Okay. Then x of s by u of s is nothing but 1 divided by s cube plus 9s square 26 s plus 24. Okay, so therefore you know x of s by u of s equal to 1 divided by s cube plus 9x square plus 26s plus 24. I am going to cross multiply this s cube plus 9x square plus 26x plus 24 into x of s, and then I am going to take u of s to that side. Okay. Okay. So you just cross multiply, you will be getting s cube plus 9s square plus 26s plus 24 into x of s equal to 1 into u of s. I am just cross multiplying this transfer function. Okay. Now I am going to multiply with this x of s inside the bracket. So you will be getting s cube x of s plus 9s square x of s plus 26s x of s plus 24 x of s equal to u of s. Okay. So I am going to take inverse Laplace transform. Taking inverse Laplace transform for the above equation. Okay. So I am going to take inverse Laplace transform for the above equation. Okay. So in inverse Laplace transform, how will you write? S is nothing but d by dt, right? So s cube means s cube d of t by dt cube. So you can write the equation in inverse Laplace transform. So you can write like this. If it is s means d, if it is s cube means d cube, s square means d square. So d cube x of t by dt cube for this thing. Okay. Plus 9 into, so if you are having any constant value, you have to write as it is. Here there is no any constant value. Here 9 is the constant. So 9 into d square x of t by dt square plus 26 d into x of t by dt plus 24, only one x of s, so you can write x 24 into x of t equal to this Laplace also you have to write, taking inverse means you will be getting u of t. So u of t. Okay. So this equation you can write, if it is in d cube means in x variables you can write like this, x triple dot plus if it is d square x of t you can write x double dot in x variables, x double dot plus if it is single dx of t means 26 x of dot x plus here 24, here there is no differentiate of x of t, this is only x of t, so you can write x. equal to u of t. Okay, then you need to assign the state variable. Assign the state variable. So assign the state variable. x1 I am going to consider as x. So x1 is nothing but x1 I am going to take it as x. x2 I am going to write it as x dot. x3 I am going to take it as x double dot. x3 dot I am going to write x triple dot. Okay, therefore you just substitute the assigned variables in this equation. So you will be getting x3 dot plus 9. This x double dot you can write x3, right? So 9 x3 plus 26 x2, because it is x dot I am just consider as x2 plus x I am going to take x1. So 26 x2 plus 24 x1 equal to u of t. So once you have taken the inverse Laplace transform, you just assign the state variable for these terms. Okay, if it is x triple dot means you have to take 3 variables, x1, x2, x3. So you got this equation, right? So I am going to write for x3 dot. So all the other variables I am going to take that side. So x3 dot equal to minus 24 x1 minus 26 x2 minus 9 x3 plus u of t. Already u of t is there, you just take it as it is. So x2 dot you know very well, that is x3. You have considered as x2 dot equal to x3, x1 dot equal to x2, x2 dot is nothing but x double dot or x3, x1 dot equal to x dot equal to x2. So I am going to write the state model matrix now. Once you write the state model matrix, you can easily check controllability by Kalman test. So state model matrix. So state model matrix is x1 dot, x2 dot, x3 dot, right? So you have to write the A matrix. Here you need to find out the A matrix. Then x1, x2, x3. This is the state model matrix. This is A matrix, okay? Plus B of U, right? So B, you have to write B matrix into U. This is the state model matrix x1 dot, x2 dot, x3 dot. So you have to check x1 dot, you get only the you will be getting only x2, right? x1, x3 is 0. So you just put 0, 0. The one coefficient of x2 is 1, right? So x1 dot equation is 0, 1, 0. Then for x2 dot is nothing but x3. Then these two variables will become 0. x1, there is no x1 and x2, only x3, right? So in x3, the coefficient of x3 is 1. Similarly, you just write it for x3 dot. For x3 dot minus 24 x1 minus 26 x2 minus 9 x3. Okay, so now you got the A matrix. So similarly you just find out the B matrix. There is no x1 dot equation, there is no x2 dot equation for U. Here only U in x3 equation, x3 dot equation only you are having U matrix. So x3 0, x1 you don't have any x1 u of t, only u of t you are having in x3 dot. So x1 dot there is no u, x2 dot 2 there is no u. In x3 dot equation only you are having u matrix. That also the coefficient of u of t is 1. So 0, 0, 1. Okay. So now you got A, B matrix. Now you can easily check the controllability of the system. Suppose in your question if they ask the observability, so you for that you need C matrix also. Okay, for that you need y of s plus x of s as we assigned already, right? So y of s by x of s you just taken that s plus 2, right? You just cross multiply. So y of s equal to s plus 2 into x of s. So y of s equal to s into x of s plus 2 into x of s. Taking inverse Laplace transform on both sides, y of t equal to, so for y of s if you are taking inverse you will be getting y of t. Then for this x of s you can write d of x of t by dt. For this thing you can write 2 into x of t, right? Now y of t equal to d into x of t by dt plus 2 into x of t. So you can write this differentiate of x of t, you can write x dot, right? So you can write x dot plus 2 into x of t, you can write x. So you can, x dot is nothing but already we assigned the variable as x2 plus 2 x1. This x you can write x1, already we assigned previously, so you can write like this. For output matrix y equal to, here we are having 3 variables x1, x2, x3. Here there is no x1, so 0. The coefficient of x2 is 1. The coefficient of, here the coefficient of x1 is 2. The coefficient of x2 is 1. There is no x3, so you can write 0. So the output matrix for this equation is y equal to 2, 1, 0. Like this you can convert transfer function into state model. Okay, now you got A matrix, B matrix, C matrix. Suppose if they ask to check the controllability and observability using the Kalman's formula, you can solve it. In this question they asked only check the controllability of the system. Okay, so the A matrix for the given transfer function is 0, 1, 0, 0, 0, 1, minus 24, minus 26, minus 9. And then B is 0, 0, 1 and C equal to 2, 1, 0. So once you know A matrix, B matrix, C matrix, you can check whether the system is controlled or not by Kalman test. So by Kalman's test, QC is B, AB, A square B. Because here they are given 3 cross, you got 3 cross 3 matrix, so you have to find out B column, AB and then A square B. So B they gave 0, 0, 1, so you need to find out what is AB. So AB 0, 1, 0, 0, 0, 1, minus 24, minus 26, minus 9. Your B value is 0, 0, 1. So same thing, if it is 3 row, 3 column, here you are having 3 row, 1 column. So 3, 3, you will be getting 3 cross 1 matrix only you will be getting. So 0 into 0, 0, 1 into 0, 0, 0 into 1, 0. If you are adding, you will be getting the 0 only. So 0 into 0, 0 into 0, you will be getting here this matrix 1 into 1 means you will be getting 1. 24 into 0, 0, 26 into 0, you will be getting 0, 9 into 1, minus 9. So your AB is 0, 1, minus 9. So next, see now you got B value, AB value, you have to find out A square B. So you have to find out A square B. So A into B you have to solve. So 0, 0, minus 20, 1, 0, minus 26, 0, 1, minus 9. So A square you just find out 0, 1, 0, 0, 0, 1, minus 24, minus 26, minus 9. Okay. So this is A into A. So first find what is A into A, then you just multiply with B matrix. Okay. So this is 3 cross 3, right? So we are getting 3 cross 3. This is 3 into 1. Okay. This is A matrix. A matrix. This is B matrix. B is 0, 0, 1. B is 0, 0, 1. So here we'll be getting 0, minus 24, 0, minus 26, 1, minus 9, 216, 210, 55. So you have to multiply 3 row, 3 column. You will be getting this matrix. This is A square. You have to multiply with 0, 0, 1. So you will be getting the value as 1 minus 9, 55. This is A square B. Okay. Now you just write it. Determinant of QC matrix is B, A, B, because this is 3 cross 3 matrix. So you have to write B, A, B, A square B. If it is 2 cross 2 matrix, you just stop this. So they won't ask 4 cross 4 matrix and all. So B is 0, 0, 1. Your AB is 0. AB value is 0, 1, minus 9. A square B is 1 minus 9, 55. So you need to find out the determinant of this value. So just find the determinant. So 0 into anything, you will be getting 0 only. Okay. 0 into anything, you will be getting. So after you just take this determinant. So there also you will be getting 0. Then here plus 1 into 1 into 1 into 9, 0 into 9, it will be 0. 1 into 1, it become 1 minus 1, right? So your determinant of QC is equal to 1 into 1 minus 1. So your magnitude is minus 1. So you no need to bother about the magnitude, sign of the magnitude. So you are getting some values, right? You are getting some magnitude. So the system is controllable. If you are getting here, determinant is you are getting 0 means the system is uncontrollable. Okay. Hence here determinant of QC is equal to minus 1. So determinant of QC is not equal to 0. Hence the system is controllable. Means the system is controllable. So you can design the controller for the particular system. Okay. So this is somewhat different method. So we just solve now. So if the system is given in transfer function model means first you have to convert it in state models, state transition model. Then you can, using the Kalman method, you can easily solve the problem. Thank you.